You're on.
I'm on now. My job is... now I've lost my time, that's a trick. Right, OK. Now we'll get going. My job on behalf of my participants is to say, don't come to our session at 9 o'clock because it's better than Haiti or it's better than black swans and white elephants. It's because there is no more important place to be. And fundamentally, it's because... This is unfair, you've tricked me. This is because our session isn't just about modelling the climate, it's about understanding the future. Risicare, to dare the gods, to try and forecast the future. The fundamental questions we need to ask are... You can't stop this thing, can you? Right, OK. How on earth do we figure... Right, oh, God, this is ridiculous. Right, I'm going to forget the slides. Right, let's start again. I've got, 4 minutes left. After this, all the other sessions will be fine. The key questions we have to answer are, where is it going to rain and how often? How many times are we going to face hurricanes and how strong will they be and where will they be? Will we have long, hot summers in temperate cities? In short, what weather can we expect now or tomorrow or in the future or in 10 years' time? These are the big questions we have to confront. Now, how on earth do we do that? Well, we can use historical observations as we've used. You've all seen the atlases where you see the typical temperature in Santiago or in London or where have you. And that's helpful. And we can use observations to forecast the weather for the next 5 days. But fundamentally, it doesn't tell us how extreme the events we might have. It doesn't tell us about a changing climate. It doesn't tell us about anything beyond 2 weeks' time. The trouble is that the world's so big that how on earth do we create some sort of experiment? You may have seen a dishpan set up in Chicago about 2 minutes ago. To try and create a model of the Earth, it was great, but we needed, actually, that was a bit of a challenge. So then we decided to create climate models. People thought we should be able to do climate models way before the beginning of the 20th century, but there wasn't enough computers, not enough power to take it forward. And after World War II, out of the Manhattan Project, those who were modelling atomic weapons, explosions in Princeton and elsewhere, thought, well, why don't we use these same techniques to model the weather? And they did, and that began to provide the tools and the kit to actually try and model what was happening in climate. Sorry, let me just move on a little bit further here. Right. The military began to forecast the weather not using historical observations, but using models of the Earth based on fundamental physics. And then about in the mid-50s, these same Princeton scientists said, well, actually, why don't we try and model the whole of the climate, whole of the planet? And they began to do that, and it began to actually represent observation to some degree. The next phase was the development of oceans, and fundamentally, the computer power allowed us to see the future. So my session, or my panelists tomorrow, are the commanding heights. We have two of the key centers of climate modeling in the world. Tom Knutson from GFDL up in Princeton, one of the progenitors of this whole field, and James Dunn at NCAR from Colorado. The power of modern computers is we can do more than just forecast future climate. We can forecast the very weather that makes that climate up. We can begin the early dawn of saying how bad the tropical cyclones and the floods may be in the future. But then we've got to move from hazard to risk, how much damage. I'm delighted that Peter Daly from AIR, one of the cat modelling companies, will explain how we move from understanding how bad the weather will be to how much damage it may do to the built environment, societies and populations. Howard Kunrather from up the road at Wharton, one of the leaders in the economics of cat financing and public policy, will explain how we're beginning to take those outputs from hazard and risk models to understand the economic impacts and how those impacts can be shared through public and private means at global and indeed local scales. Actually, what we're moving to now, using these same climate models, is actually the cusp of operational climate forecasting at months, seasons, and indeed years ahead. And this is critical, not just for us in the insurance industry to try and figure out how much the costs will be, but where to locate assets in the future for disaster risk reduction, or to help countries prepare with months to go, not just weeks to go. And finally, Mariam Golnaghi will be flying in from Geneva tomorrow morning. She leads disaster risk reduction at the WMO. and she'll be explaining how the WMO is going to seize upon this new technology to drive forward this agenda in partnership with the World Bank. Thank you. You're a naughty man. You're a naughty man.